We'll proceed in sum series to integral calculus. Sum series to integral calculus or integral sum series through integral calculus. This is the discussion that is not available in anywhere, anyone can search. Any book, anywhere on internet, here and there. Can we find some series through integral calculus? This is the discussion that is very near to how we can convert a discrete function into a continuous function. If someone has discrete function, these have immense use in electronics and in electromagnetic radiation. Has immense use where someone can have discrete signals and he can think about the continuous signal, because once you get continuous function, once you get a continuous function, then calculus would work on it. Otherwise, on discrete function, calculus would not work, because discrete function only summation works. On discrete function, normal summation works. Whereas on continuous function, integral calculus works. And to convert discrete function into continuous function, two ways we are suggesting. There can be other ways also. What is the way that we can convert the discrete signal, discrete function into continuous function? Okay, and one of them that we are trying for the past two times is 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 plus 5 by 6 plus n by 1 plus n. N terms are there. There are n terms. 1 by 2, we take numerator as the number of terms. 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 plus 5 by 6. 5 items are there. Plus n by n plus 1. N items are there. If there are n items, then can we convert this item into a continuous function? If I am able to convert this into continuous function, then we can calculate the next summation, net summation. Okay, as usual, we divide the problem into n different parts, and then we will tackle part by part. First part is 1 by 2, second part is 2 by 2, 2 by 3, sixth part is 6 by 7. Okay, in that manner, can we go ahead and can we think about something where each part behave same? Yeah, certainly it is. If it is x by x plus 1. Okay, if I have 5 plus 5 as 5 into 3, 5 into x, where x is 3, 5 dx, integration 0 to 3. Similarly, can we proceed like this? We have x by 1 plus x by 1 plus x plus x by 1 plus x plus x by 1 plus x plus n times. Can we rewrite it as x by 1 plus x into x? The way we did 5 plus 5 plus 5, 5 into 3, 5 into x, where x is 3, 5 dx, limit 0 to 3. This is called repeated addition. We are adding same thing repeatedly. What we are adding same thing repeatedly is x by 1 plus x, where x is variable. This result may not be very accurate, because if I want repeated summation to convert into integral calculus, repeated summation will first come in the arena of multiplication. Then multiplication will finally turn into integral calculus. Multiplication of two items. One is function over x and another is x. One is function over independent component multiplied by if I have function over independent component multiplied by the independent component, it will turn into integral calculus. Function over x, x is independent component. Function over x is dependent upon x. Fx into x, fx dx, from 0 to whatever number we want. So x by 1 plus x is fx into x terms. X by 1 plus x into dx, from 0 to n. This may not be a very perfect solution, because for this to have, the fx should be a constant. If it is constant, then it works perfectly. But at least we get a signal that how the problem can be solved. What can be? We have talked about it. If I do the integration of this, we get the solution. Please watch our previous video. We have talked about it in detail. Anyway, second way is called successive approximation. This is one way in integral calculus x by 1 plus x dx from 0 to n. There is another way called successive approximation. That was repeated addition turned into multiplication and then turned into integral calculus. Now we have another fashion, and that is called successive approximation. Successive approximation means can we convert our discrete function into continuous function? How we convert our discrete function? What is discrete function? Discrete function is x by 1 plus x. How it is discrete? It looks like continuous. X by 1 plus x. Yeah, this looks like continuous, but it is sampled at x equal to 1, 2, 3, 4, 5, 6, something like that. It cannot be sampled at x equal to 1.5 or something like that. Okay, what I mean is, go. Okay, okay. What I mean is, okay, so what I mean is this is x-axis. This is x-axis and this is fx. This is fx. Fx is going, this is fx. X equal to 1 means it is 1 by 2 half. This is fx and it is going till more or less 1 only. 10 by 11 is near to 1. 100 by 101 is more near to 1. The function is going like this, and this function is sampled at x equal to 1, 2, 3, 4 like that. It cannot be sampled at any arbitrary point. It must be an integer value. It must be a whole number without any fraction. Okay, what I'm saying is if this is x-axis, this is x-axis, this is origin. This is origin. This is x equal to 1, 2, 3, 4, 5, 6. If it is like that, then there is a function like this. If it is like that, then there is a function like this. If there is a function like this, then it is sampled at x equal to 1. That is half. Then x equal to 2. That is 2 by 3. Like that it will grow. So this function is sampled at different x. X equal to 1, it is half. X equal to 2, it is 2 by 3. X equal to 3, it is 3 by 4. X equal to 4, it is 4 by 5. At x equal to n, it is n by 1 plus n. This function is sampled at different locations. Means there is no continuity here. And it has verticals. At different x, it has verticals. I'm trying to add the vertical. Okay. The question is arising, can I convert this discrete function into a full place continuous function? Gx, this is fx, x by 1 plus x. Can I have another function? Can I have another function called gx? Okay, what is your another function gx? Yeah, this function is gx. Gx can be sampled at any x. X equal to 3.5, x equal to 2.29, like that. This is a full continuous function. Then how you, what sum you will get? It can be between 1 and 2 only. Between 1 and 2 only, it can be sampled at infinite places. Then what you will get? How you will get? Calculate the summation. What do you want? I want summation x equal to, summation means sigma sign. Sigma x equal to 1 to n function over x. What do you mean? Function over x plus function over x plus function over x plus function over x plus function over x n time. X equal to 1 to n time function over x. What is function over x? That is x by 1 plus x. X by 1 plus x plus x by 1 plus x plus x by 1 plus x n time, where x will vary. First will be 1 by 1 plus 2, 1 by 1 plus 1, plus 1 plus 2 by 2 plus 1, plus 3 by 3 plus 1 plus 4 by 4 plus 1, n by n plus 1. This is what I want. Okay, means you want summation of all the verticals. Looks like you want summation of all the verticals. Yeah, I want summation of all the vertical where vertical are available, vertical are real only at x equal to 1, 2, 3, 4, 5, 6, not in between anywhere. Okay, thank you. We will try now. What you will try? I'll try to I shall try. I shall try to represent these verticals. I shall try to represent these verticals into. I shall try to represent these verticals. What I we will try to represent this vertical through a continuous graph. How you will represent a vertical through continuous graph? Okay, there are set of verticals. How you represent through continuous graph? Can we think? Can I have? We have an idea. What is the idea? X equal to 1, x equal to 2, x equal to 3. Don't you see there are gaps here? X equal to 1 to 2, there is a gap here. X equal to 2 to 3, there is a gap here. X equal to 3 to 4, there is a gap here. If there is a gap like this, then can I take a area in between x and 2, area like this, and this area would go and hit one function called gx, which is a continuous function. Makes sense? Yeah, this is gx. Understood? This is another function called gx, another function gx. And take one area between x and x equal to 1 and 2. We are starting from x equal to 1. Yeah, right. We are starting from x equal to 1. Then between x equal to 1 and x equal to 2, including x equal to 1 and excluding x equal to 2, there is an area between x equal to 1 and x equal to 2. This area, if I take this area strip, it will go and hit this function gx, and then there will be area strip here. Yeah, there is area strip here. True. There is another area strip here from x equal to 2 to x equal to 3. True. There is another area strip here, x equal to n minus 1 to x equal to n. True. How many areas are there? If I say x equal to 1 to x equal to n, how many areas will come? The area will be exactly n minus 1. If I start, if there are two, x equal to 1 and x equal to 2, then there are one area only, whereas verticals are two. What are you trying? I'm trying to represent each vertical with each sub area. If there are n number of verticals are there to be added, then there should be n sub area. Then you have to add one more. 1 to 2, one sub area. 2 to 3, one sub area. Then you have to proceed, and n to n plus 1, there will be last sub area. Then each vertical will be represented by a sub area. What do you mean? At x equal to 1, there is a vertical in fx, that is 1 by 1 plus 1, 1 by 2. 1 by 2 will be represented by one sub area, that is between x equal to 1 to x equal to 2. This sub area, and this sub area will go and hit this line. Okay, this is the sub area. Okay, this sub area, this is gx, this is fx. Fx is x by 1 plus x. This is gx that we don't know. Fx is a discrete function, gx is a continuous function. We have one imaginary gx function for which, if I try to calculate area between x equal to 1 and x equal to 2, this area will go up and hit gx. This is a sub area of gx between x equal to 1 and x equal to 2. My imagination is, if this sub area, the amount what we are getting, if this is exactly equal to fx, that is x by 1 plus x, that is 1 by 2, at x equal to 1. If x equal to 1, fx is 1 by 2. If this 1 by 2 is exactly equal to gx, area between x equal to 1 and 2, then this sub area represent fx at x equal to 1. Means 1 by 2 equal to integration 1 to 2 gx dx. For each vertical, I have one sub area. The sub area that will represent the vertical at x equal to n, the vertical at x equal to n is n by 1 plus n. and then their sub area is gx dx from n to n plus 1. Now, if I'm adding all the verticals, sigma summation sign x equal to 1 to n fx, if I'm adding all the verticals, then equal to okay, equal to summation we can also write here as summation x equal to 1 to x equal to 1 to n, x equal to 1 to n, or if it is cumbersome, then we can write x equal to 1 to n fx, summation of all the vertical where fx is x by 1 plus x. That is same as n here also there is the n number of summation, n number of summation in integral calculus, where first summation, first one here, first amount is x by 1 plus x, that is a vertical. Here first amount is a sub area between 1 and 2 gx dx plus 2 and 3 gx dx plus 3 and 4 gx dx. What are you trying to say? I'm trying to say you have 1 by, we have 1 by 2 plus 2 by 3 plus 3 by 4. This is what the addition is, 1 by 2 plus 2 by 3 plus 3 by 4. This addition will become integration 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4. Here we have 1 by 2 plus 2 by 3 plus 3 by 4 up to 3 only. But it will go 3 to 4 gx dx. Now against each vertical we have each subsection. So integration of 1 to 2, 2 to 3 and 3 to 4 will exactly become 1 to 4 gx dx. What do you mean? I am saying summation x equal to 1 to n fx equal to integration of 1 to n plus 1. Here it is 1 to n. Here it will be 1 to n plus 1 gx dx. Okay, then nice, you did it. Okay, we have to find gx. That is the problem. If I find gx, then it will be exactly same and we can crack it. This is something $1 trillion base. If someone proceed more on this, this may come in future if it someone was very accurate in differential equations also. Okay, but no problem. But this is the path someone has to take. Thank you very much. What can be another way? Here only there can be another way. If someone is very avid watcher, then he would say, boss, you did very nice job. But what is guarantee warranty? You tried from 1, 2, 2, 3 like that. You took a vertical at x equal to 1 and then you match this vertical with the area region from 1 to 2. Right side you took. Can you take left side? And both should be same. Can you take left side and both should be same as per the fundamental of calculus? Yeah. Then we will take first section from 0 to 1 and that should be equal to at x equal to 1. Second section we will take from 1 to 2 and it should be equal to x equal to 2. Left side we are taking now. Then last section will be from n minus 1 to n. What are you trying to say? Means summation x equal to 1 to n fx equal to integration from 1 minus 1, that is 0, 0 to n gx dx. Here gx will come differently. I would rather say g2x dx. Means summation x equal to 1 to n fx equal to integration 1 to n plus 1 g1x dx equal to integration 0 to n g2x dx. Okay, concept is all three should be exactly same. First we don't. Second, I have to find g1x. Third, I have to find g2x. If I find g2x, then g2x dx integration from g2x and g1x will be different. But g2x integration from 0 to n, whatever we are getting in term of n, it should be exactly same as g1x integration from 1 to n plus 1. That will also come in term of n only. That will be exactly same as summation x equal to 1 to n fx x by 1. That will also come in term of n only. All three must be same. Okay, first two we have tried. Please watch our previous videos. First two we have already tried. Okay, If you have already tried first two, then what is there? Third one we will try. What is third one? Third one means, consider this is fx. Fx means x by 1 plus x, and this is gx or g2x whatsoever. Gx, and gx means, if I take, now we have to go left. Why? If there is a vertical at x equal to 1 and it is 1 by 2, this vertical should be exactly same as the sub area from 1 minus 1, 0, between 0 to 1. This is the sub area that will go hit gx here. Gx dx from 0 to 1 should be exactly same as fx1, should be exactly same as fx1. Okay, then you will do part by part or what? Then again you will do from 1 to 2 gx dx, and that will be equal to fx at x equal to 2. Then how many times? Okay, let's take any. Let's take any. Any means what? Any means, let's take any x. Let's take any x equal to x. Yeah, x equal to x. At that time, what is the fx? Fx is x by 1 plus x. Then we have to take left side. Then what will be another one? It will be x minus 1. If it is x, then it will be x minus 1. What is the sub area between x and x minus 1? This sub area is x minus 1 to x dx dx, and that sub area should be exactly same as fx. Makes sense? If fx at x equal to x, whatever the height we are seeing, that is x by 1 plus x, that height should match the area calculation through integral calculus dx dx from x minus 1 to x. If both are same, then we have to find gx, and then we are done. Then we will try with x equal to 1, 2, and then finally we will try with n, and it will come in equation of n only. Anyway, how you validate? Okay, we don't know the answer. Whatever it comes, it should be all right. Anyway, we will try now. So what is fx? Fx is 1 by 1 plus x. That is same as 1 plus x minus 1 by 1 plus x. X means x minus 1 plus 1, same thing. So it will come as 1 minus 1 by 1 plus x. We want 1 minus 1 by 1 plus x, that is the fx, equal to gx dx. Okay, then gx will be differentiation of this, and that will come as 1 by 1 plus x. 1 n and n, it will come as minus natural differentiation of 1 minus 1 by 1 plus x. Differentiation of minus 1 by 1 plus x. This will come as 1 by 1 plus x whole square plus positive. We'll try gx. First, gx is 1 by 1 plus x whole square dx. Integration will come as minus 1 by 1 plus x only. Limit is x minus 1 to x. If I put x, then it becomes minus 1 by 1 plus x. Minus minus plus, plus 1 by 1 plus x. X is x minus 1. X means 1 by x minus 1 by x plus 1. This is how it will come. Okay, how much it will come? X minus 1 minus x. Then it will come as minus 1 by x into x plus 1. Minus 1 by x into x plus 1, where denominator has order of 2, x order of 2, numerator has nothing, whereas the actual result what we are looking for is x by 1 plus x, where numerator is of order 1 and denominator is of order 1 only. So these are completely different. Completely different. How much different they are? Actual we want is x by 1 plus x, and we are getting minus 1 by x into 1 x into 1 minus x. If I divide these two, x by 1 plus x by minus 1 by x into x minus 1, it will appear as x into x into x into x minus 1 by 1 plus x, something like that. Something like that. Okay, then how much it will come? X into x, x into x whole square, 1 minus x by 1 plus x. This is the terminology that we have to multiply what we did earlier. So what earlier gx was 1 by 1 plus x. Now multiplied by x square into 1 minus x by 1 plus x. This is the x. This is the something that we need to multiply to get whatever we want. Earlier we had 1 by 1 plus x whole square dx. Now we have to multiply with the x square, 1 minus x divided by 1 plus x. Okay, this is extremely cumbersome. Extremely cumbersome. Okay, let's rub it off. Let's try with the whatever is there in the fx. Make sense? We'll try. This is, after all, this is successive approximation. So we'll try with x by 1 plus dx and x by 1 plus x. If I try, then it will again become 1 minus 1 by 1 plus x dx. It will become x minus natural log of 1 plus x. Limit x minus 1 to x. Okay, if I do, I have to find gx. If I support it, 1 minus net x minus natural log of 1 plus x, limit x minus 1 to x. If I place x, then it remains same, x minus natural log of 1 plus x. Okay, or if I settle down part by part, if I settle down x first, the limit is x minus 1 to x minus x minus 1. It will come as 1. 1 minus, let's settle down log 1 plus x. Log 1 plus x minus log x. 1 plus x minus 1 plus 1 plus x minus 1 x. It will come as minus, and in bracket log 1 plus x minus log x. It will come as log 1 plus x by x. If I take out this minus as plus, the net will become 1 plus natural log of x by x plus 1. Okay, 1 plus natural log of x by x plus 1. X by x plus 1 I can rewrite as numerator of x at x plus 1 minus 1. So it will become a natural log of 1 plus 1 by 1 plus x. Makes sense? Okay, if I do the Maclaurin series in this uh, log of 1 minus 1 by 1 plus x, this is what it is coming. Net is coming as 1 plus natural log of, in bracket, 1 minus 1 by 1 minus 1 by 1 plus x. If I expand it through the Maclaurin series, then the expansion of log 1 plus x through Maclaurin series is x minus 1 by 2 into x square plus 1 by 3 into x to the power 3 plus, sorry, minus 1 by 4 into x to the power 4, and so and so. Now we have natural log of 1 plus 1 by 1 plus x, natural log of 1 minus, if I said plus then it is wrong, 1 plus natural log of, in bracket, 1 minus 1 by 1 plus x. If natural log of 1 minus 1 plus x, if I expand, then it is, then I have to expansion of 1 plus x, I know. Consider x is minus 1 by 1 plus x. If I expand it, then it will come as minus 1 by 1 plus x minus 1 by 2, and in bracket minus 1 by 1 plus x whole square plus 1 by 3, and in bracket 1 by 1 plus x to the power 3, like so. Okay, if I settle down, it becomes minus 1 by 1 plus x minus 1 by 2 into 1 by 1 plus x whole square minus 1 by 3 into 1 by 1 plus x to the power 3 minus 1 by 4 into 1 by 1 plus x to the power 4. All will be minus 1 all. Okay, now settle it down. We got the integration as, if, okay, we had got that after putting the limit integration, we started with the gx equal to 1 minus 1 by 1 plus x, and then we did the integration at x minus natural log of 1 plus x. Then we filled the substitution, then we put the limit from x minus 1 to x. Then it resulted as 1 plus natural log of x by 1 plus x, and that become 1 minus 1 by 1 plus x. I expanded it, and finally it came as 1 minus 1 by 1 plus x minus 1 by 2 1 plus x whole square minus 1 by 3 into 1 by 1 plus x to the power 3, like so. We will take up to a square only because it is difficult to, someone can write on paper. There is no hindrance here. There. Okay, now we have 1, if I take first term only, then it is 1 minus 1 by x. That is exactly same as fx. Fx is also 1 minus 1 plus x only. Means we are on right track. Gx is x, dx. Dx from x minus 1 to x. If I take first term only, then it is exactly 1 minus 1 by 1 plus x. That is what fx is. We are on right track. If I take up till here only, we will have some solution, but it is expansion. Next is minus 1 by 2 into 1 by 1 plus x whole square. This is extra we are getting. It should not have been like that. The answer is dx from x minus 1 to x. I have to find gx in a way that dx from x minus 1 to x should result in exactly fx at x equal to x. Fx at x equal to x is 1 minus 1 by 1 plus x. But here, after doing all the computation and putting limit x minus 1 to x, we are getting 1 minus 1 plus x. That is all right. But extra we are getting a right hand side through Maclaurin series expansion. And then minus 1 by 2 into 1 by 1 plus x whole square, minus 1 by 3 into 1 by 1 plus x to the power 3, minus 1 by 4 into 1 by 1 plus x to the power 4, like so. Okay, in that fashion, we will take up to x square only. If I take up to x square, first two term 1 minus 1 plus x is same as fx. So no problem. This is unwanted. Minus 1 by 2 into 1 by 1 plus x whole square. So whatever gx we have taken, reverse of it we will means we will add there so that the solution will be neutral. Okay, so we will add there. What is there? Now we have gx we had taken 1 minus 1 by 1 plus x. There we will add 1 by 2 into 1 by 1 plus x whole square. It came as negative, we will add it so that it will normalize each other. We'll try again. 1 minus 1 by 1 plus x minus, sorry, plus. Here it was minus, so it will come as plus 1 by 2 into 1 by 1 plus x whole square. If I do integration, if I settle it down, then it will come to the same. First two will, from my x minus 1 to x, first two will come exactly same. What is the same? 1 plus natural log of 1 minus 1 by 1 plus x. This is what we had received. Let's settle down the last one. Last one is plus 1 by 2, 1 by 1 plus x square. If I do integration of this, then it will result in minus 1 by 2, 1 by 1 plus x. If I settle down x minus 1 to x as limit, then top x will remain as same, minus 1 by 2 into 1 by 1 plus x, minus plus 1 by 2, 1 by 2, 1 by x plus 1, x will become x minus 1, means it will become x. More or less, this term will become 1 by 2 into 1 by x minus 1 by 2 into 1 by 1 plus x. I can take out 1 by 2. 1 by x into 1 by x minus 1 by x plus 1. Then it will become x plus 1 minus x. 1 by x into x plus 1. Makes sense? It will become now 1 by 2. 1 by 2 into 1 by x into x plus 1. This is what extra we are getting. If I break the second term, what we are getting now? 1 plus natural log of bracket 1 minus 1 by 1 plus x plus 1 by 2 into 1 by x into x plus 1. If I break this natural log, then it will come as minus 1 by 1 plus x. This is all right. This is wanted one. Second term is minus 1 by 2 into 1 by 1 plus x whole square. This is unwanted thing, and that is neutral. Minus 1 by 2 into 1 by 1 plus x whole square is neutralized by plus 1 by 2 into 1 by x into x plus 1. More or less they are same only. Means it got neutralized. If I expand what we have got now, if I had taken gx equal to 1 minus 1 by 1 plus x, plus x plus 1 by 2 into 1 by 1 plus x whole square. If I've taken new gx like this, then if I expand Maclaurin series, then it will come like 1 minus 1 by 1 plus x. This is what the wanted is. Then rest is extra we are getting. What is the extra? Minus 1 by 2 into 1 by 1 plus x whole square plus 1 by 2 into 1 by x into x plus 1. Here it is minus 1 by 2 into 1 by x plus 1 whole square, and here it is plus 1 by 2 into 1 by x into x plus 1. They are exactly same, little bit different. So more or less we can cut it down and say it is 0, 1. Means we have found gx, and gx is, we can say gx is 1 minus 1 by 1 plus x my plus 1 by 2 into 1 by 1 plus x whole square. Someone can proceed more in Maclaurin series, more perfect result will come. Or here what we got, it is not exactly same. It should have been, if I had taken, if our full integration x minus 1 to x, full integration x minus x is what gx we had taken. Okay, hope. What gx we had taken? Gx, what is coming at whatever we have taken new gx, the new gx whatever we have taken now, here it is coming as a kind of if I hope people understand what I'm trying to say. I'm also confused a little bit. Someone has to try on the paper. Anyway, what we are saying, if I had taken 1 minus 1 by 1 plus x, this is fx, as gx also, then there was then we did integration and substituted limit as x minus 1 to x. Then we received 1 minus 1 by 1 plus x. That is true. Extra we got as plus 1 by 2. Extra what we got as minus 1 by 2 into 1 by 1 plus x whole square. This is what is unwanted we are getting. To have the wanted, then we instead of here it is subtraction, we added it. Once we added it, then we try again x minus 1 to x, and then we are getting 1 minus 1 by 1 plus x. That is all right. Then minus 1 by 2 into 1 by 1 plus x whole square plus 1 by 2 into 1 by x into x plus 1. These two we are considering as 0. If it is 0, then full terminology exactly same as fx, that is x by 1 plus x or 1 minus 1 by 1 plus x. Okay, but this is not 0. 1 by 2, 1 minus 1 by 2 into 1 by 1 plus x whole square plus 1 by 2 into 1 by x into x plus 1 equal to not 0. Because here one term is x plus 1 and here one term is x. Next term is x plus 1, next term is x plus 1. Little bit minute difference is there. Someone has to settle down this minute difference with another approximation, successive approximation. Successively, we are approximating gx. What will be, what gx we take, that gx dx from x minus 1 to x will exactly become fx. Then we have found, but we will go through it. It is very less is remaining. So we can claim that gx is 1 minus 1 by 1 plus x plus 1 by 2 into 1 by 1 plus x whole square. This is gx. If this is gx, then what is the net solution? Net solution is, if people remember, we said net solution is summation x equal to 1 to n fx equal to limit 1 to n plus 1 g1x equal to 0 to n g2x. This is g2x we have found, and g2x, that is left side, g2x is 1 minus 1 by 1 plus x plus 1 by 2 into 1 by 1 plus x whole square. Let's go with it. g2x dx integration limit is 0 to n. We'll try now. Okay, g2x dx, if I try integration, it become 1 become x. Integration of 1 is x. Let's settle x from 0 to x. That will come as x1 minus logarithmic 1 by 1 plus x. Integration will be logarithmic of 1 plus x base e. Logarithmic of 1 plus x from 0 to x, 0 to n. First we become n minus, and natural log of 1 plus x 0 to n. Then natural log of 1 plus n minus 0 log of, it will be 0 only. Means n minus natural log of 1 plus n. If people remember the last time when we are trying right hand side, it came a natural log of n plus 2. Here it is coming as natural log of n plus 1. Both are different. So n minus natural log of n plus 1. N plus 1. Okay. And then now we have to settle down plus 1 by 2 plus 1 by 2 1 by 1 plus x square. Integration will come as minus 1 by 2 into 1 by 1 plus x. Then we have to settle 0 to n. If I settle n, it will become minus 1 by 2 into 1 by n. If I settle 0 as x, then it will be minus minus plus 1 by 2 into 1 by 1. It will become 1 by 2, constant, plus 1 by 2. Plus 1 by 2 means net solution coming is n minus natural log of 1 plus n minus 1 by 2 into 1 by 1 plus n plus 1 by 2. Someone can proceed in Maclaurin series and going more in successive approximation. Let's try n equal to 1. If n equal to 1, then first n is 1. 1 minus natural log of 1 plus 1, 2. Natural log of 2 is 0.7. So 1 minus 0.7 is 0.3. But actual answer is 1 by 5, 1 by 2, 0.5. Let's proceed now. Then minus 1 by 2 into 1 by 1 plus n minus 1 by 4. 1 by 4. So now we have, that will result in 0.25. Right now we have 0.3. 0.3 minus 0.25, 0.5. 0.5 plus 1 by 2, 5.5. Okay, I have not taken many other things. Answer is 0.5 and we are getting 0.55, very near to each other. We'll try n equal to 2. If n equal to 2, then n minus natural log of n plus 1. N is 2 minus natural log of n plus 1. Natural log of 3. Natural log of 3 is 1.1. 2 minus 1.1 is 0.9 minus 1 by 2 n plus 1. N plus 1 is 2 plus 1, 3, 3 into 2, 6. Minus 1 by 6. 0.9 minus 1 by 6. 1 by 6, how much it will come? 1 by 6 means 0.17. 0.9 minus 0.17, that will come as 0.73. 0.73. I think so. 0.73. So it will come as 0.73 plus 1 by 2. 0.73 plus 1 by 2, 0.5. It will come as 0.23. 1.23. 1.23. Let's try here. N equal to 2 means 1 by 2 plus 2 by 3. 0.5 plus 0.67. That is 1.17. 1.17. 1.23. Okay, this is what we are getting. Again near. What extra we are getting, that will be settled down if I take a long term. Anyway, let's take n equal to 3. Then n minus log of n plus 1. N is 3. Log n plus 1, that is natural log of 4. That is 1.4. That is 1.4. So 3 minus 1.4, 1.41 or something like that. 1.41. So if I subtract 3 minus 1.41, then it will become like, how much it will become? 3 minus 1.4, it will become 1.6, 1.59 rather. Let's remember 1.6. 1.6, now we have 1.6 minus 1 by 2 n plus 1. N is 3 now. 3 plus 1, 4 into 2, 8 minus 1 by 8. Okay, 1.6 minus 1.8. Okay, minus 1.8. 1 by 8. 1 by 8 is 0.125. 0.125. Okay, 0.125. Right now we have 1.6. 1.6 minus 0.13. Let's say 0.13. 1.6 minus 0.13. It will come as 1.47, I believe. 1.47. 1.47 plus half, that is fixed one. So 1.47 plus half will more or less it will come at 2 only. 1.97, something like that. 1.97. Let's try here. 1 by 2 plus 2 by 3. 1.5 plus 0.67. 1.17 plus 3 by 4. 0.75. 1.67 plus 1.17 plus 0.75 will come as 1.92. Here we are 1.97. Now it is approaching. Whatever, since beginning only it is perfect. 1.9 to 1.97. Someone can try more. This is something that is not mentioned in any of the book. Anyone can try. Successive approximation, converting any discrete function into continuous function, and through successive approximation, and then adjusting the limit exactly. Then someone would say, do you have anything that is exact? Everywhere talking about, please watch our previous video. We are trying with 1 by x, 1 by x. That's why it is coming in natural log, and then we are. Otherwise, if I take numerator like fx equal to x that we have tried, all are coming exactly perfect. Probably we will try exactly perfect. These are not available in any of the book. If someone search, there is approximation, and the way they bring it, no one can understand it. And the way the formula they derive, that also no one understand it. Harmonic term, then this term and this constant and that constant. So many things they dump that people run away from their one. This is much simple and much more accurate. Anyway, please do not mind supporting us, mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +9 in the country code. 9483160610 is the telephone number. Okay, when we had taken right hand side, limit was from 1 to n plus 1. I remember it came as n minus natural log of n plus 2 minus natural log of, plus natural log of 2 minus something plus something like that. And here, if we had taken left hand side, 0 to n, then it came as n minus natural log of n plus 1. There it was n plus 2. There plus natural plus log of 2. Here there is nothing like that. And then there was minus plus. Here minus is minus 1 by 2 into 1 by n plus 1 plus 1 by 2. And there I think it was 1 by 4 or something like that. But end result are exactly same. We can compare.